Unit 9, Topic 4, Arcs and Central Angles. An arc is a section of a circle. We can see an arc is that little curve on the outside. Remember that the circle is only the curved line, not what's inside. And now let's talk diameter. A line through the center of a circle that has endpoints on the circle is a diameter. So if we have the center here and we draw a line through it, that is our diameter. Today we're going to be learning about a central angle. This is an angle whose vertex is on the center. It is equal to the arc it creates. So the center is going to be our vertex, which means that we're going to have two lines that come off of it. The angle formed by these lines is going to be our central angle. I can see that these two lines, if I draw a line between them, form an arc. This will be the arc across from the central angle. Remember that all of the arcs in a circle will add to 360 degrees. Let's talk minor arc. So this is an arc that spans less than half the circle. So if I have a diameter, the minor arc will not be able to hit both endpoints. It's going to be smaller. A major arc is an arc that spans more than half the circle. So if I have a diameter, the major arc will be able to pass it. It's going to be larger. And lastly, we have a semicircle. This is an arc that spans exactly half the circle. That is, from one endpoint of a diameter to another. All right. So if we have the diameter, a semicircle will go from one endpoint to the other. A semicircle will equal 180 degrees. It's half a circle. All right, so remember today, we are going to look for diameters, vertical angles, and right angles. The arc measure is going to equal the central angle. Adjacent central angles will be added to make bigger central angles, and adjacent arcs can be added to make bigger arcs. So, find the indicated angles and arcs. Let's solve for angles first. So we're told that the measure of angle BDF equals 148 degrees. So let's draw it into our circle. From B to D to F, the angle is 148 degrees. Now we need to find the measure of angle A to D to B, right here. Well, I know that the angles form a diameter, and the measure of a diameter is 180 degrees. So if I take 148 degrees and add it to the measure of angle ADB, it's going to equal 180 degrees. So I subtract 148 degrees from both sides, and I'm going to find that angle ADB equals 32 degrees. Excellent. So now let's solve for the measure of angle FDC. Well, I can see that angle ADB and angle FDC are vertical angles, so they must be congruent. Now let's solve for the measure of angle EDC. So from E to D to C, I see that it's across from the arc EC, which is 70 degrees. Because central angles equal their intercepted arcs, angle EDC is going to also be 70 degrees. Now let's look at the measure of angle BDE. So from B to D all the way over to E. Well, I see that angle BDE and angle EDC form a straight line, that diameter. So angle BDE plus angle EDC must be 180 degrees. Well, I know that angle EDC is 70 degrees. So angle BDE plus that 70 degrees has to be 180 degrees. I'll subtract 70 degrees from both sides, and that tells me that angle BDE will be 110 degrees. Now let's find the measure of angle F to D to E. All right. I can see that angle F to D to E is made up of angle FDC and angle EDC. So if I take angle FDE, it will equal FDC plus EDC. So angle FDE is going to equal 32 degrees plus 70 degrees, and angle FDE will be 102 degrees. Now let's solve for the arcs. But first, we'll write in all of our angle values. So B to D to A was 32 degrees, same as F to D to C. So to solve for angle A to D to E, I see that B to D to A and A to D to E and E to D to C all form a diameter. That means that angle A to D to E plus that 32 degrees plus the 70 degrees will equal 180 degrees. So angle ADE plus 102 degrees will be 180 degrees. I'll subtract 102 from both sides, and I find that angle ADE is 78 degrees. All right. So now, because central angles are equal to its arc, we can find our arcs. So starting with the measure of AE, I see that the measure of AE is 78 degrees. Now let's find the measure of A to C. I can see that A to C is formed by A to E plus E to C. So the whole thing AC will equal AE plus EC. So arc AC will be 78 plus 70. That is, arc AC will be 148 degrees. Now, arc F to B to A. I can see that arc F to B to A is composed of, oh, it's a diameter. It doesn't matter. Arc F to B to A has to be 180 degrees. Now, let's look at arc E to F to B. All right. Arc E to F to B is arc EC plus arc CF plus arc FB. So arc E to F to B is 70 plus 32 plus 148. That is, arc E to F to B is 250 degrees. Now let's find arc A to C to B. Wow, that's almost the entire circle. And I know that the entire circle is 360 degrees. So if I take the whole circle, 360 degrees, and remove that little arc, AB, I'm going to find that arc ACB is 360 degrees is minus 32 degrees. So arc A to C to B is 328 degrees. It's the entire circle except that little 32 degree segment. So the measure of ACB is 328 degrees.